Welcome all to this talk on doing redline testing with OpenSearch Benchmark. I know it's a post-lunch session, but the talk is fairly simple and small, so I hope we'll have your attention. Yeah, before we dive into it, just a quick introduction about ourselves. I'm Rishabh Singh. I have Michael Oviedo with me. We both work for AWS OpenSearch, focusing mainly on performance engineering side of it, and we are also active maintainers of OpenSearch Benchmark. So what's the agenda for today? It's fairly simple. We'll quickly go over what OpenSearch Benchmark is, what static load balancing looks like, load testing looks like, and how we have made it dynamic and improved it, and what is redline testing and why it might be useful for you. So what is OpenSearch Benchmark? In case you haven't already used it, it's the de facto benchmarking tool for OpenSearch. We use it extensively for performance testing, and we also use it to track any regressions on OpenSearch mainline by running nightlies using OpenSearch Benchmark. And it has varying set of workloads ranging from simple text queries, range queries, histograms, going up to supporting AI/ML workloads like vector search, semantic search, hybrid search, and we also recently added SQL queries as well. So before I dive into static load testing, let's assume a scenario where you run an e-commerce company and your product search is powered by OpenSearch, and you have a big sales event coming up, let's say Big Friday, and you're anticipating a good spike in your traffic. Let's say the average traffic on your website is 1,000 requests per second, and you're like at least expecting 5x. So what do? You need to scale up your capacity to handle the load and make sure the end user still maintains the same service latency without impacting any performance. So to get there, you want to use OpenSearch Benchmark. And how static load testing works is you say, okay, let me baseline my current cluster. Let's see how much traffic it can take. And then from there, we can use that calculation to go calculate how much new capacity you would need to maintain the load on actual day. So if you say OpenSearch Benchmark, let me double the traffic, let's say 2,000 clients per second, 3,000 clients per second. So how OpenSearch Benchmark would work in this case is it would spawn all 3,000 clients at the same time, and it will start sending load to your cluster. So there's a very good chance that your cluster might not sustain the traffic, and it can break immediately within the minutes after you start the benchmark process. So the downside is your cluster is breaking, but you don't know at which point it broke. Like maybe it broke at 1,500 requests per second, maybe at 2,000, maybe at 3,000, you don't know. And how you figure it out, you will mostly scale it down. Maybe let's say, okay, let me reduce by 500 clients and try again. And it breaks again, you don't know at which point it broke. And suppose you finally get the stable cluster, but your service latency is not what you expected. So if you follow me, this process is very, very time consuming, very repeatable, a lot of manual churn. And you're mostly guessing all the time. So guessing result would not give you confidence in the final results, and this would most likely result in you either being over-provisioned because you want to be cautious, or you could be under-provisioned if you're conservative in your approach. So to fix this and improve the end-user experience of using OpenSearch Benchmark for load testing, we introduced this new feature called Redline Testing. What it does is it introduces a new feature called feedback, where we are listening, or OSB is listening to your cluster health all the time. It tracks different metrics, and it automatically ramps up or ramps down the client count. At the end of the run, it would tell you, okay, your cluster was able to sustain so-and-so load. To give more details onto it, I would want to invite Michael, who will take over it.
Cool. All right. Thanks for that intro, Rishabh. So let's talk about redline testing in OSB. So redline testing is a feature that Rishabh and I introduced recently. Like you mentioned, it's going to enable OSB to, rather than just keeping those static client or throughput values during a load test, OSB is going to be able to adjust them dynamically during runtime. So these numbers are adjusted based on your cluster's performance in real time. So OSB is listening to your cluster and determining whether it can or cannot handle more traffic. if it can, we continue to scale those numbers up. Otherwise, if your cluster is doing things like violating any SLAs you might have in place or returning errors, we go ahead and scale those numbers down. The goal of redline testing is to find your cluster's maximum stable throughput count. So we sort of purposefully increase the traffic until we find your cluster's breaking point, by which point we scale that traffic back and sort of continue to come back and forth until we find that niche where your cluster can handle the amount of traffic that it's at, but no more. So we're sort of looking for that ceiling. All right, so what changed? Like Rishabh mentioned, before this feature, if you wanted to sort of find your cluster's max throughput count, you would have to do this guessing game where you would pick some arbitrary throughput number, test your cluster with that throughput number. Maybe it breaks, maybe it doesn't, and you'd go on from there, continuously rerunning tests, monitoring for failures or whatever cluster, or however your cluster is behaving in the logs and dashboards, until you find a number that you're happy with. All right, so how does it work? A redline test is going to start us off with a very gentle load. So we're actually going to start from 0 clients, ramping this number up, all the while listening to your cluster with this feedback loop that Rishabh mentioned already. So yeah, OSB is measuring each request's latency or whether it's returning any sort of errors, and again, adjusting that load dynamically based on how your cluster is behaving. So as you can see here, in this chart we have in the background, this is showing the average throughput count for my cluster during a redline test. So you can see that the general behavior is to slowly ramp up that throughput at the beginning, and you can see it taper off there towards the top where we've sort of found this ceiling for my cluster. All right, so I want to take a look at redline testing under the hood, but before then I want to give a little bit of a background on the actor system. So OSB is built using the actor model, meaning there are a bunch of different isolated components, each individual for different parts of running a load test. So some of them might be responsible for preparing the workload that we're going to be using. Some might be responsible for sending the actual queries. These actors communicate using message passing, and the idea is that they can all run asynchronously, but together to orchestrate a load test without running into any sort of issues. That being said, here is a very high-level visual of what redline testing looks like under the hood. So on the left, you can see OpenSearch Benchmark. Over on the right, you can see the target host, so that's meant to represent your OpenSearch cluster. And in between, we've got a few different components, one of which being the worker. So the worker is one of those actors that I mentioned, and it's responsible for spinning up these processes called the clients. So clients are asynchronous processes that are all responsible for sending the individual requests to your cluster during a load test. So when we added redline testing to OSB, we added a new actor called the feedback actor. So as you can see, the feedback actor and this client up top are communicating back and forth. But really, the feedback actor is doing this with all of the clients. So this is representing the back and forth feedback loop that we've mentioned a few times now. So during a test, if a client runs into any sort of issues, maybe a request timed out, or maybe we just got an error response for some reason, it's going to communicate this with the feedback actor via a multi-processing queue. So this queue is thread safe, and it's constantly monitored by the feedback actor. So if the feedback actor detects any sort of error messages in the queue, it's going to take action and scale down the amount of traffic being sent over to your cluster. All right, so how does it control the traffic? Well, there's another thread safe dictionary that we added to OSB where the key values are these client IDs, and the values themselves are Boolean values where true tells a client, yes, you can go ahead and send requests. False means no. So each individual client has its own key in the dictionary, and it checks this key to see whether it should or shouldn't be sending requests before taking any action during a redline test. So like Rishabh mentioned before, OSB is still going to spin up these 1,000 clients or however many clients you might have defined at the start. The difference here being that during redline testing, we are not sending all the traffic over at once, rather slowly ramping it up to find that cluster's breaking point. All right, So what do you get out of redline testing? Well, knowing your cluster's max throughput capacity can help with several things. Like all these points above, capacity planning, regression detection, cost optimization, or just giving you the general confidence that your cluster is going to be able to handle what you think might get thrown at it on that big day. All right, so that being said, let's run a quick demo of what a redline test would look like. So I'm going to go ahead and open up the terminal here. And on this terminal, I've already got OSB installed and a cluster ready to be tested. But before we get into the test and actually run it, I wanted to give a little bit more background here. So here I've just done a cat on the test procedure that we're going to use. So in OSB, a test procedure is essentially a set of instructions that tells it, hey, let's run these queries in this manner, in this order. So in this case, we've got a test procedure with just one query here, the range auto date histo. So OSB can run queries in two different modes. The first one being iteration based. So we tell OSB, hey, I want to run this query 100 times, and it's just going to run it 100 times and move on. In this case, we're using the timed mode where we give OSB a value in seconds. So in this case, we've given it 1200 seconds. So it's going to run this request repeatedly until those 20 minutes are over. All right, so over here in this window, I've got the command ready. All right, so if you've used OSB before, this is going to look familiar. If not, all we're going to do is invoke OSB with the OpenSearch Benchmark. We're going to tell it that we want to run a load test, and then we're just going to pass in that workload and test procedure that we just talked about. And then this target host is just going to be the cluster that we're testing. Now to make it a redline test, all we have to do is add this -- redline test flag. So if I go ahead and run that, it'll spin up in a second. Okay, cool. So yeah, again, if you've used OSB before, this will look pretty familiar. So we're running this query here. It's going to show us the percentage of how far along in the test we are. For redline testing, we've also added this printout here that gives you a live view of how many clients are sending those requests over to your cluster. So if we take a peek at the logs, we can see a little bit about what's going on behind the scenes. So you can see that the feedback actor here is running in 1 second intervals. If there are no errors in the past 15 seconds in this case, we go ahead and randomly sample 10 clients from that dictionary to scale up and start increasing the traffic that way. So this is going to take a while, obviously, so I'm going to go ahead and just cancel it. And I have some screenshots here showing what you might see during a redline test. So if you've used OSB, you'll know this test summary report is generated at the end of every load test. For redline testing, we've also added this printout here at the bottom that's circled that tells you the maximum throughput that your cluster was able to handle for that test. Here's a screenshot from the logs showing what it looks like when we reach an error. So at the top there, circled in red, you can see that this client, number 1015, timed out after a second. It went ahead and reported that to the error queue. And you can see there at the bottom that the feedback actor saw that there were 5 clients active, paused 2 of them, leaving 3 remaining. And then here's another chart showing the average throughput value for my cluster during another redline test. So as you can see here, again, the trend is to slowly ramp up that throughput value. We wobbled a little bit there in the middle, but we did sort of stabilize there at the end, eventually finding my cluster's ceiling. All right, customizing your redline test. So yeah, there's a few knobs that you can turn to sort of fine-tune your redline test and change it. So first up is the scale step. So we saw that the feedback actor was running in those intervals and unpausing a number of clients every second. So you can customize how many clients you want to unpause with this scale step flag. Then there's the scale down percentage, which is a little more self-explanatory, but OSB takes a percentage of clients rather than a specific number when it needs to scale down, so you can customize that from the default of 10%. Then there's the post scale down sleep. So after scaling down, OSB, or rather the feedback actor, will sort of give your cluster a break and stop any sort of scaling just to let your cluster adjust to that new throughput level. Then there's the max clients flag, which defines that ceiling, so how many clients we want to spawn in the beginning. So yeah, if you want to change it to 2,000, 3,000, 5,000, however many you want, you would pass that in for this flag. Then there's CPU-based feedback. So there's a few more flags related here, but this basically enables OSB to, rather than scaling up or down based on request errors, we scale based on your cluster's CPU usage. So for CPU-based feedback, you will need a data store connected, which is just another OpenSearch cluster that's going to go ahead and store your test results and metrics. So for CPU-based feedback, OSB will then query this data store and get an average of your data node's CPU usage over the past 60 seconds. So you can customize that test with the CPU max usage flag. So if you want to not go over 90%, you would pass that into here. For the window seconds, if you would rather take the average over the past 90 seconds or maybe 30 seconds instead, you would specify that there. And then for the check interval, this is just to define how often you want to check your average CPU usage. All right, so yeah, we think redline testing is really cool. We've got a few best practices here, just some high-level tips. We recommend running against staging or isolated clusters. So this is just to help reduce any sort of outside noise that might affect the test. Use workloads that reflect your queries. This is a little more obvious, but you definitely want to reflect your production environment as best as you possibly can. Have clear thresholds defined, so if you have any sort of SLAs that you need to meet, you should have those ready before running the test. And then repeat runs just to confirm that your cluster is actually stable at that level. All right, so some key takeaways. We think redline testing can lead to smarter benchmarking. It's meant to find your cluster's true breaking point, or rather that point right before the breaking point. And it's going to help save on costs, prevent outages and downtime, and just help you build that confidence that your cluster can handle what you think is going to be thrown at it. And beyond that, it can also help with other sorts of testing like regression tracking, testing different configurations or new index settings, and comparing different hardware or cloud instance sizes. All right, so if you're interested in redline testing, please do give it a try. I've got the command pasted up there, but if you can't read that, you can go ahead and head over to our documentation website where we talk about the feature in a lot more detail, as well as the blog post that we released upon releasing the feature, where we talked about how we designed it and why we made the choices that we did. Cool. Yeah, thank you guys for attending. We've got a couple minutes if anybody has any questions. Oh, man. Yeah.
Are there any recommended instances to run OpenSearch Benchmark depending on the type of cluster that you're trying to run?
Yeah, I mean, so far we have been able to achieve up to 10,000 clients on, I guess, C5 4x large. So the bigger the instance, the more clients you can spawn. And we also support distributed load generators, where you can have multiple nodes generating traffic against your cluster.
All right.
Is it only benchmarking the open data nodes, or the OpenSearch data nodes, or it can also benchmark the ingestion layer as well, like data prep or dispatch?
So far, it's just the OpenSearch cluster. Yeah.
And it's looking for the errors within the data nodes, like circuit breaker.
Yeah.
Is it measuring the index difficulties?
Yes, it does.
All right. Oh man. You right there. You've had your. Yeah. No. You. Yeah.
So how do you redline ingestion with query where, depending on your configuration, you could handle more ingestion or more query simultaneously? So it looks like your presentation was on query side.
Yes, it's more tuned towards queries. I'm not sure about the parallel ingestion and search, but yeah, if OpenSearch Benchmark does support parallel ingestion and search, and believe the overall architecture should be able to support it, but yeah, we haven't really run those tests yet. But ideally, it should be able to. run the same because it's the same for both. I think at the back he's been.
Okay.
Yep.
Is there a way to correlate the latency of each request with like the level of traffic at that time, or do you just kind of get the percentile from the whole ranking?
Yes, it does. So for that, we recommend, so basically OpenSearch Benchmark has two modes of data store. One is in-memory, which is default. If you use in-memory, all you get is a final result. But if you want to track your performance benchmark live as it's running and see how each client is coming up and how latency is going up or throughput is faring, we recommend to use a dedicated data store, which is an OpenSearch data store. You can provide that configuration to the config file. And what it does, as the benchmark is running, it will sample every second the metrics and it will ingest into that data store. So you can have visualizations built on top of that data store, and you can see how your current benchmarking is going on and how your clients are ramping up and how the latency is going up or down, same with throughput. And it also tracks CPU and JVM usage as well. So you can track that as well. Yep.
Okay, so now we benchmark it and we know the cluster is down. What's next? So what's the recommendation? What's the recommendations on this? What we can tune on the cluster size to make sure that it can survive with more DPS and other things? Is that in your scope, or is that something that you are thinking about to do with our
Well, once you get those results, if you, let's say for that big day, you might need to reach like a 3000 TPS. If your cluster could only reach a 600 TPS, then during a redline test, then you know that the next recommendation should be to scale up. But if your cluster was able to reach, maybe 4,000 or 5,000, then, you can have that confidence that you should be okay on that day.
Yep.
Does the tool have integration? Can I index the benchmark logs, the results, and counters?
Yes. That's what I just discussed. So it has two modes of data ingestion, metric ingestion. One is in memory, where you just get the final results. But if you can use OpenSearch basically it's a different OpenSearch cluster that you would use as a dedicated data store, and you can give that configuration into benchmark. So what it'll do is, like, as and when it's running, it'll keep ingesting the live metrics to that other data store, and you can have your visualizations and you can query that.
All right.
Okay.
If there's nothing else, we can also take individual questions offline.
Yeah.
Yeah, thanks guys.